So welcome once again guys, to our sessions, and we are continuing from the first principles video. Against to those who have watched our first video that we posted on first principles today, and at this point I would want us to be able to see how do we determine derivative from first principles. But in this case I want us to be able to see, if we are given f of x, which is in fraction format, how do we do that, and at what stage do we need to be able to solve fractions. So to those who are just joining us at this point, make sure that you also spare a moment to just hit the button of subscription, and also don't forget to hit notification button, so that more videos as they are coming, you will be able to get notified on those videos that we shall be posting. So let's get into our content for the day. So like I said, we are on first principles. So step number one, just like what we said before, that we need the formula, which is limit as h tends to 0, f of x plus h minus f of x divided by h. So this is the formula all the time. Whenever you see these words, first principles, do not forget your formula, which is this formula. So like I said before, we need to be able to separately determine f of x plus h. So f of x plus h is simply whereby on our original function, the given function, at the position of x, just put x plus h, 1 over x plus h. F of x, like what we need to do, f of x is the same which is given function 1 over x. So at this step, we are going to substitute our f of x plus h. Just remove everything and you substitute this. Subtract, remove everything, substitute this. So limits as h tends to 0, we have 1 over x plus h, subtract 1 over x, everything divided by an h. So f of x plus x is this, minus f of x is this one, everything divided by h divided by h. So the next step, we want to be able to solve these two fractions. So I guess you know how do we solve fractions. Solving fractions, what you need to do, let me just give an example of how do we solve fractions here. So if, for example, you are given 2 over 7, then minus 3 over 8. How do you solve this fraction without using calculator? What we have to do is to multiply the denominators. Multiply the denominators, or we have a way of saying you need to find what is called the lowest common denominator, which is a number where 7 can enter and 8 can enter without leaving a remainder. So that number, so we are going to find it by multiplying the 2. So in this case, 7 times 8, let's have our 7 multiplied by 8. After that, we need to cross multiply. 2 times 8, 2 times 8, subtract 3 times 7, 3 times 7. This is how we normally simplify a fraction when two fractions are subtracting each other. So we want to use the same concept on this numerator here, 1 over x plus h, subtract 1 over x. We want to use the same concept. For now, let's a little bit ignore this h. Let's simplify the numerator. So just like in this fashion, we are going to, let us wrap this, just as you have seen how we did this. We want to do it on these two fractions. Let us wrap this so that we can use this space. And what we are going to do, we are going to solve 1 over x plus h, subtract 1 over x. In the same way, or in the same fashion, we have our common denominator. We multiply x plus h multiplied by x. So we are going to cross multiply. 1 times x, we have x. 1 times x plus h minus, but 1 multiplied by this bracket, we are going to put in a bracket x plus h multiplied by 1, it remains like that. I guess you know that anything multiplied by 1 remains the same. So let's open the bracket. We are going to have x minus h divided by, we are going to divide by x enters here, x squared plus xh. So we are going to have our final answer, which is x minus x becomes 0 minus h, so negative h divided by x squared plus xh. What we have just done, we have simplified the numerator. Now let us bring back this on this position. So we have limits as h tends to 0. We are rewriting this, but our numerator is no longer 1 over x plus h minus 1 over x, is now as this, since we have simplified on this one. So if we now have minus h over x squared plus xh. But I want you to get to understand one thing. This sign over h, you understand, it also means divided by h. So I'm not going to use this over h, I'm going to use the sign of divided, since it means the same thing. I guess you understand that if we have 1 over x is the same as 1 divided by x. I guess you understand this. This is the same thing. We want to use it on this one. We want to remove this over and put divided by. So let us do that. Then we are going to have divided by h. H, let's make h as a fraction. H as a fraction becomes h over 1. Say writing as h and writing as h over 1 is the same thing. Anything divided by 1 remains. So let's close our square bracket. So next step, we are going to remove this divided by, substitute with a multiplication, then we invert process of solving fractions. So if you still remember, we have this, what we have learned from lower grades, that 1 over x divided by 2 over y can be written as 1 over x multiplied by y over 2. So when you remove divided and put multiplication, you invert them so that the numerator goes on the denominator goes on top like this. So I guess you can see the way we're explaining this, so that every step of the way until the answer, you will be able to know it and also to repeat it on your own. So let us remove this limits as h tends to 0 minus h over x squared plus xh multiplied by 1 over h. So once we've done that, these are going to cancel, these are going to cancel. When they cancel, we are left with limits as h tends to 0 with 1 over x squared plus xh. Now h can be 0 now, because the idea of substituting h as 0 is to make sure that we don't substitute h as 0 where it's compromised and the whole denominator becomes 0, so that it becomes invalid. We are trying to avoid that. So we are at a stage where h can now become 0 without making the whole function to be invalid. Our final answer is 1 over x squared plus x multiplied by 0. So final answer 1 over x. So this is how we derive first principles when there's a fraction. So thank you so much for watching our video. We are going to see you on other videos as we continue. Thank you.